Okay, no one talks. Silence. Silence. Okay, remember, back in Unit 3, okay, back in Unit 3, November, test was in December, I gave you a flashcard that said something like this. When you encounter a problem on the AP test where they ask you to find the value of a constant, you need to ignore the constant. You need to do other calculus things that are familiar and normal and regular, and then eventually you'll do enough steps and you'll find the constant. Just don't worry about k. Just think of k as being 5. So this says 2 times 5 is like 10x minus x squared. So we don't want to focus on k. We just want to do steps and eventually we will find k. So looking at this problem, one person please raise your hand and tell me, if we pretend that there's no k, what would you kind of expect we should do as a very, very first step? Legal. No, listen close to this. Hold on. Factoring out an x is legal. I haven't typically found it helpful. Other suggestions? Yeah, we're trying to find this integral. If I ignore k, it's just like, well, I got to find the integral. So I just split it. Again, I just do that in my head. So I need the antiderivative of 2kx. Remember, 2 is a multiplier. K is also a multiplier. So this becomes, don't forget the equal sign. Just say it out loud. What's the derivative of x? Sorry, antiderivative. What's the antiderivative of x? X squared divided by 2. Okay, does anyone need me to talk more about that? You're okay. Think of it this way, Chris. If you were doing an integral that looked like this, again, we're using the fundamental theorem, so we're integrating some derivative of something. So we want to find the antiderivative instead and bar it. So what's the antiderivative of 10x?
It's going to be x squared, or 10x squared divided by 2.
You're comfortable with that?
Yeah.
Good. So when you have k involved in a problem, you just have to think of k as being a constant. So this would be like 2 times 5, which would be 10. Or maybe 2 times 7. But it's just a constant, just like the 10. It's not affected by anything.
Okay. I guess I was thinking kind of like, isn't x kind of the same thing though? Because we're kind of putting in.
Oh, the difference. It's good questions. Hey, the difference is x is actually any value between 0 and k. But k is one value. That's why we refer to k as being a constant. So what makes them seem like they're the same is we don't know the value of either one yet. But eventually we'll learn the value of k, and it's just a number.
Yeah.
Where x is many numbers.
Yeah.
Does that help?
Yeah.
2 points. Anybody else? Please, Evan.
How are we allowed to just use that as a constant? Wouldn't it be like an expanded rule
The thing you have to always remember is k could be 5, 6, 7, 8, 9, whatever. So if we knew k, we just say that's 10, and we just write down 10.
Yeah, but I don't
Keep going. There's 2 reasons why the expanded rule doesn't apply. Are you thinking of the expanded rule like this? Like if you had, like are you thinking that this would require the expanded rule? You can use the expanded rule here. It's just not productive. If you look at the pink sheet, it says if the exponent is 1, don't use the expanded rule. So it's not wrong, it just isn't helpful. So it's better to not use it. Instead, what I used was the fact that 10 is a multiplying constant, so it doesn't do anything. And then the antiderivative of x is just x squared over 2. So in the same way, 2 times k is a multiplying constant, it doesn't do anything. And then the antiderivative of x is x squared over 2. You got 2 points? The antiderivative of x squared is x cubed over 3. Okay, look. I got to keep warning people. Bad habits are creeping in. Look at me. Everybody look at me. Everybody. There's a couple of bad habits I just cannot tolerate. You cannot pick up your phone during class. Like, there's times when I'm walking the room and things like that, it doesn't ever bother me. Like, you're just kind of waiting. But when we're discussing, you can't do that. It just breaks my concentration. It breaks your concentration. You can't. What do I do next? Hands, come on. What comes next? Hands. More hands. What do I do? I'm ignoring K, but I just need to do familiar things. Talk, we gotta get more hands. Like, what comes next? Hands up, come on. Well, the talking didn't help very much, got like the same hands. There we go. Bar it, or Wilson never really caught on, you know.
What? I literally catch myself saying it.
And I was like, you like that one?
That's the only thing I
Some people like, I don't know. Whatever. Okay, how many know? Point 2 for Carson. Somebody raise your hand, earn a ticket, and tell me, how is the item in green related to the expression in red? Let's go, Sophie.
The item in red is the antiderivative of the item in green.
Perfect. We're just using the fundamental theorem. Question? Here's what I'll pay a ticket for. I haven't said this in class. I'll feel bad, but the AP test is worth 108 points. I've said before, approximately this number of points is only available to those who understand and can use the fundamental theorem. Like, without an understanding of this, you cannot get this many points. 30. Okay? To get to get a passing score on the AP test, you have to get about 48 points. So 30 of the 48 can be had. I mean, you need to know some other things, but without a knowledge of this, you cannot get 30 of them. Like, this is the most important idea on the entire test. Okay, please.
Since you're multiplying 2k and x squared and then dividing it that part by 2, couldn't you just simplify that to k x squared?
Yeah, because look, the thing to always remember is this is really just a bunch of fractions. It's like 2 over 1, k over 1, x squared over 1, 1/2. And when you're multiplying, you choose the order. So I'm going to multiply 2 times 1/2 first. That becomes 1. So now I have this. 3 points for Tori. Take 4. Take 5. 5's good. Okay, I made a huge mistake when I was working this problem. I'll pay a ticket if somebody can raise your hand and tell me what's the huge. It's really simple, but it's a mistake from the very beginning. Like the first thing I wrote down, this was an error that I'm always telling you not to make, and then I went and made it. So, Mary?
This is just a guess, but okay, I feel like this is wrong. But I think this is wrong. You didn't write the. Okay, I think this is wrong. I don't want to say it.
Good.
Okay, you didn't write the first whole equation down like you didn't write the.
Like this part here?
Yeah, you didn't write
Oh, no, I'm paying you a ticket for that. Because I've said many times that if you write down the equation you're solving in your work, you'll learn it better. Like your brain just will remember far better if it can see that. I didn't rewrite it just because that's already in front of me, but you don't have that. You have to write it down, and I'll pay for that. Hey, the mistake I made is related to that. If I had done what Marin said, I don't think I would have made the error. So what's my mistake, Sydney?
You forgot the dx.
There's no dx here. Look, because remember, the integral of f prime is the same as the antiderivative of f prime barred, or Wilson. So no dx, so we don't need that. 2 points. What's my mistake, Alex? Okay, listen, hey, look up. Listen, I made a big deal about it just a minute ago, how you don't want to just move things around. You want to understand what's equal to what. Equal is the key. The key is the equal sign. And I messed up. The whole key to this problem is maintaining what's equal to what. So you put together what Marin said and what Ali said, it goes together very well. That's why you write this to begin with on your paper, so you remember, hey, this integral is the same as this due to the fundamental theorem. But if this integral is equal to 18, then this must also equal 18. Like you have to have it. Okay? Raise your hand if it was raised a moment ago and you would have said exactly what Ali said. Well, suppose you didn't have such a word. Carson.
Do you need the equation sign on both sides of the, has the equal sign on both sides of the equation?
No. Yeah, it is true that this is equal, but since I've got one here, I don't need one here.
Okay.
Yeah, good comment. 2 points. Okay, again, oh, sorry, please.
Do we need parentheses around the negative x cubed prime or over 3? Did you need parentheses?
Because there's only one term, I don't. If there were multiple terms, I would need that.
I didn't even notice.
Because we were very focused. Julia. Sorry, Sarah. Hey. Guys. Chris, question.
Oh yeah, so is it equals 18? Is that saying like in 0 and k the area is 18?
Assuming that the curve is always above the x-axis. If the curve crosses the x-axis, that's not true. So. 2 points. Okay, look. No one talk now. So I told you a minute ago, when you're trying to find k, you just keep ignoring k. Just keep doing what normally is done, and eventually you'll just find k. So just plug it in. Take away the x, put in parentheses. Okay, now Julia, I have to have parentheses. Because it's going to be minus, and there's going to be several things that follow. When you have minus only one term, you don't need a parenthesis. But I'm going to have multiple things, so for sure, parenthesis there. And all of it must equal 18. That's all zeros, so that's kind of convenient. Question? You want me to talk about anything? There's multiple ways to solve the problem at this point. Here's my suggestion. Okay, again, I'm trying to get all of you to think as you work, not just move stuff around. This says I have 1 k cubed. This says I have 1/3 k cubed. It's like cooking. Really. You have 1 cup, 1 k cubes, 1 something, minus 1/3 of k cubed, what do you have? 2/3 k cubed. So no, that's wrong. 18 times 3 is not that. 54? There we go.
Wait, what if I like don't know what
You gotta break out your fingers. Really? There's no other option. You just, yeah, so you just have to, you know.
Do we do the big calculator first or the second one?
It's kind of mixed. I'll show you a trick I do. It works for lots of AP questions. Just see how you. You're okay. Hold on. Quiet. Okay, what I'm trying to show again is just kind of the way to think through it versus math through it. Because I think you're way ahead if you're thinking versus mathing. K is whatever. So I just have, I have 1 whole whatever. Then I have 1/3 of the same whatever. So you have a whole of something minus 1/3 of something, what do you have? You have 2/3 of that something. Is that your question?
Yeah, I was wondering how you got it there.
The math way to get there is to say this needs to have the same denominator as this. So you say I've got 3 k cubed over 3. Because the 3's would divide out and have k cubed. Minus k cubed over 3. Well, when you subtract fractions, bottom stays the same, and you just subtract the top. So 3k cubed subtract k cubed would be 2k cubed over 3.
So hard.
Point.
Why can you stop on
Only.
Oh,
They wouldn't give one like this in their No, because there's no way to. Yeah, you'd have to go just as far. I did get your question. Hold on. Look up. No one talk. Listen to Carson's question one. Look at me. Silence. There's no guarantee that multiple choice answers come out clean. I would say most of the time, yes. But to keep you honest, they throw in questions that don't. Yeah. Now, Sydney had a good question. She's like, can't quite remember what 3 times 18 is. Here's what I do. Look at me. Come on, don't talk. Answer this. Raise your hand as quick as you can and tell me, like as quick as you can. Just raise your hand. What's 3 times 20? Hands up. See how fast everyone raised their hand? Oh, look at me. Fast, right? 60. Well, 18 is only 2 away from 20. So what's 3 times 2? 6. So 60 minus 6 is 54. That's how I do it. That makes sense.